Hey steampunks, my name is Ash and I'm with Team STEAM Robotics. So for those of you who are new or maybe aren't familiar with us, we are a FRC Robotics competition team based in Lawrence, Kansas. We have about 50 team members who work tirelessly all year round to ensure that we are able to go to a competition. That competition is held by FRC Robotics. They support over 80,000 robotics teams worldwide, and that encompasses over 1 million people who are involved either as students, like me, or as coaches and mentors. So that's a brief overview of who we are, what we do. So what we're going to be doing today is I'm going to give you guys a tutorial on VEX Virtual Simulator, and then access to the playground, how to use it all, and then I'll turn it over to you guys for a challenge. VEX is very similar to FRC, where they have the same ideals of teaching kids about STEM and encouraging that passion for it, and they host their own competitions. However, VEX and FRC are not the same. But VEX has been incredibly gracious enough to provide a free service that allows us to program one of their bots and to do tasks like driving forward, shooting a basketball, picking up tiles off the ground, much like it would in real life. So let's hop to it. Alright, so here is what a new block code project looks like. In order to access this, you can go to vr.vex.com as highlighted in the search bar. Or you can just Google VEX Virtual Reality, VEX VR, and it should pop up as the first result. Or you can just go to VEX's website and just navigate it along the top bar. So here it is. From first glance, it very much looks like Scratch. And so you have block coding, you have all of your operators and things you need along here, and you can customize variables. But what is cool about VEX VR is if you go to Playground up here, once this loads, that is. Alright, it'll show you the field that you are going to be working with. And if you go to this button down here, it gives you a 3D model. And that's honestly pretty cool. My robotics team uses virtually the same thing whenever we're trying to train our programmers how to drive forward, pick up objects. So it's not too far off from what we do. So yeah. Alright, so the objective is we want to destroy all of these castles, demolish them. We want to drive through, and hopefully you guys don't use my advice when you're taking your driving test. So, let's get back to the grid and see how far we need to go. So, this right here, the square field, is actually a coordinate plane system. So, we're at -800 here for the y coordinates, and we're exactly in the middle of x. So, if you think about a graph that you see in math, we're at the origin, down a little. So it means that right here, where we want to go, is 0, 0. And all the way across the field to go right here is 1600. And then 800 that way, and 800 that way. Technically this is -800, but you can't have negative distance, so. Alright, so now we have to tell the robot what to do. We can't just mentally communicate with it and hope for the best. We have to give it specific instructions in order for it to process it and run. So let's see what it does when we just tell it to drive forward. For example, let me get into the 3D view here. Alright, so it demolished the castle, which is great, but because we did not tell it to stop, it won't stop, it'll just keep on falling forever. Alright, so let's tell it to drive forward a specified amount, so that way we drive through the first castle. If you guys can see here on the top right, we are about 557 millimeters away from the castle itself. So we need to drive a bit past that in order to have enough momentum to keep going through it. Otherwise, we'll just bump into it and we won't really get like completely objective. So let's drive forward about 800 millimeters. Oh, and in case you're not comfortable with millimeters yet, you can also change it to inches. So it really just depends on your preference. You'll have to do calculations based on the location either way. All right, so let's see how far we go with 800. All right, so we used up a lot of our energy in order to just go through the castle itself. So that's why we did not go the full 800 meters like we hoped to. Alright, so we have effectively destroyed, hold on, that was the wrong button, I'm sorry. 3 out of the 4 castles, okay. And because this one is a bit bigger than the other 3 that were lining the perimeter, I'm going to show you guys what I think is really fun about this. Okay, so let's repeat the same old process where we turn right for 90 degrees and then we drive forward. I'm going to say about 800. And for the record, we don't have to turn 90 degrees. Like, for example, you could have turned like right here, left there. You could have done so many different kind of combinations, but this is just the easy path that I'm showing you. And if you want to turn here and like provide a different angle so you'll be able to go through the middle of the field, then go for it, honestly. Like, the possibilities are truly endless. Okay, so here we go. We're going to set drive velocity to a big number. Whenever we set the drive velocity higher, that means that we are telling the robot to speed up. So let's set this to some kind of ridiculous number right here. So that way it's easier to get momentum, so we can just crash through that ending palace. Castle, not palace. My bad. Okay, then let's drive another 800 meters from there, because this is about 1600 units across. Alrighty. Ooh, okay. And then you can also change the camera angle, so we're not stuck facing it that way, and it doesn't feel like the bot is coming towards us and like trying to run us over. That's fine. Alrighty. Did you guys just see it sped up a little there? Alright. And so that is the demonstration that I have for you guys today. Now here is my challenge for you. If you go back up to the activity selector in the playground and you go to Dynamic Castle Crusher, it loads different configurations of palaces. And so, yeah. And so it's not always one here, one here, one here, and one here. You'll have to calculate it differently, so that way you still are able to hit all of the castles. And then once you're done with that, you keep on hitting this one to refresh. And as I said, you guys can change the angles, you guys can change the drive speed, and you guys can change how far forward you move. So I'm expecting greatness from you guys, because I think that you guys can do it. And there are about 5 different configurations, but every time you try to like redo your code, it'll give you a different configuration, and that can be pretty frustrating. So if you guys like failed code for the first time, but you don't want to try a different configuration until you have that one down pat, just refresh it until you get the configuration that you guys want. And another really quick thing that I want to show you guys, and then here are like other challenges, but specifically about Castle Crusher, is if you guys go right here, it'll show you guys the code that you've wrote as actual lines and not blocks. And so all of these are commands that we gave the bot, like right here. And then another quick thing, if you don't want to try with blocks like this, if you go to File, New Text Project, let's click discard there. It'll give you guys the same thing, and these are all comments, so everything with Octothorpe in front of it, that won't execute as actual code. If it's green, the bot doesn't really read it as code, it just ignores it. So you're free to write down common steps that you want to take. And you guys can drag it here if you want, like we did with the block, or you could also type it out if you want more of a challenge. The language that VEX uses, or that we're coding with right now, is Python. And so if you guys find this really intriguing, I'll include a few resources in the description below. Alright, and furthermore, VEX has tutorials and learning on the website. Oh wait, it actually did not go to that tab, but if you press the learn and tutorials up there, it'll take you there. So the goal is just to get your feet wet in programming and just give you guys a place to start. And it's not really underestimating your abilities at all, because as I said, our programmers use pretty much the same tactic whenever we are programming a robot for actual competitions. So then there are other activities on the playground that you guys can do if you get bored. If you finish all 5 of the configurations, please click tell your parents, or you can go to the website that we will link to for some prize. So that is all that I have for you guys content-wise today. Thank you so much for joining us. I really appreciate it.